Hi, and welcome to this Elliott Sound Products guitar preamplifier build part 2, coming up next. Greetings, the Astro 30 here yet again on this Elliott Sound Products guitar preamp, and I've been to JCar and I've got the correct 120 picofarad capacitors, 50 volt, cost all of about 38 cents for the two. I don't have the connectors yet. I'll get them tomorrow and it'll all be filmed in the one video, so don't worry, and we'll get to the front panel, the control wiring, input jacks, and all that such and such, and testing all in this video. So some of you may be asking an important question: does it really matter if the value is 120 picofarad or 220 picofarad? Well, yes. So a quick look back at the schematic. This is the input stage. The other stage is the same, uses the same capacitor. This is going across its feedback resistor, the negative feedback resistor, and this actually does give a little bit of high frequency roll off. So if you use a higher value capacitor there, it's not going to give you the same high frequency roll off that value would. This value has been specifically chosen and should be the value you use. If it was like 110 picofarad versus 120 picofarad, there wouldn't be much in it. But Rod has chosen this particular capacitor for a reason. We are going to stick with that capacitor. We're not going to modify any circuits because the results that you get may differ to how he's designed it, and he's not going to be held responsible if you complain to him that it doesn't work as desired, or it starts to end up in high frequency oscillation. That's another reason that cap's there. I did also have a thought here. I'm going to add a couple of more PCB pins here, one in the output and one on the low input, just to make it easier for testing purposes. You'll see why a little bit later. So now that the board is populated, that makes it awfully difficult to do this, but I'm going to try anyway. So I might use my side cutters, although yeah, I might be able to do that, just to get it to hold there, and we'll see how straight I can solder this. I think that's soldered. Look at that, that is perfectly straight. Oh, I'm good, just ask me. Alright, I'll do the second one now. I said the low input. This one's going to be a little bit more awkward because it's close to this capacitor and I can't hold on to the stupid thing. The fun and games of assembling a circuit board that's already assembled. I mean, adding things like this in makes it a lot more difficult. Same sort of method. Hold it with the side cutters so I can turn it over and let gravity do the rest. Not as straight, but it'll do. That's pretty good actually, I think. Alright, now onto these two capacitors. So we rip the bag open, and now that's C4 that I've got to populate, and wherever the other one's gone, C10. These two here. So I'll just also verify these are the correct capacitance as well. Yeah, 121, 121, that's 12 with 1 0, so 120. It's always good to verify. Again, I'm going to put these in the correct way around so that the electrons don't fall out. Just trying to figure out which way around the resistors went. I'm pretty sure it's that way around. I mean, it's not polarized, it doesn't matter, I just like being anal. So there's one. can't quite see what I'm doing. There's two. Now we just need to solder them in place. There's not much light here at the moment because I didn't bother moving the light, but we'll get there. Trim off the excess, like so. That one there. I really do need to get smaller cutters. That's a bit better. That one's a bit long too. There we go. Oh, that joint's a bit crap now. I'll fix that. Easy. Alright, so those are the two capacitors now in. Now I can move on to the sockets. I'm going to have two ways. One for the DC, one for the out. Two 3-ways, one for the master, one for the input. And a 6-way for the time control network.
24 hours later.
Alright, it's the next evening. I've been to JCar and I've got some more parts. I'll just show the catalogue numbers for people playing along at home. Got two of these 2-way headers with crimp connectors, which are a pain in the ass, HM3402. I've got two 3-ways, HM3403. I don't actually need these parts at the moment. I've got a 6-way, which is a HM3406, and I'm not sure of the catalogue numbers on these, but I've got some 2-ways, 3-ways, but they're the right-angled 3-ways. I'd have to bend the pins out to make them stand upright. So I'll open this little polythene bag here and get out what I am actually going to be doing today, which, well, at this point in time in the video, is putting these connectors in. Excuse me. So what I mean about these is I'll just take a pair of pliers and I'll gently bend these back straight without breaking the connector. Which doesn't often work too well, but it's semi-straight. Once I get it in the board, it should be alright. And for instance, I'll stick it in the master position, like so. Then I solder that in, and then I cut the excess lead length off, and it should be right. So, just adjust my light a bit. This might prove challenging to... I could use the side cutters for that. So I'll grab my soldering iron. I don't know why they don't have the normal 3-ways in there, but it is what it is. That does not want to solder for whatever reason. Yeah, got it that time. It moved. So yeah, that's in, but now one of my pins are bent, which is great. Right, that one turned out less messy. This one kind of a bit skewiff, but here's what it is. So this one's going to go over here, and hopefully this one solders a little less eventful. I've mentioned before that I hate these type of connectors. I always have. Never liked them one bit. But it is what it is. So that's nowhere near straight. Still not straight. It is now. Don't know why the pin decided to sink down like that, but it did. So I'll just carefully solder this pin here. And I'll try and solder this pin without shorting it like I did the last one. is something as simple as soldering connectors, and I can still manage to bugger it up. No, it's not bridged. At least I don't think it is. No, it's not. If I can run my meter probe in between the two, it's fine, it's not bridged. Okay, so that's the connectors in, albeit that one's crooked, but what can you do? Yeah, that's functional. That DC socket's overhanging a bit, but that's fine. Just to verify that I've got a ground connection there on the output, stick one of my multimeter probes there. Indeed, this should be free floating of ground, which it's not. That is in the wrong spot. This is what happens when you don't pay attention and you rush things without double checking your work. A three-way connector would have probably worked better here in this situation. I really need a helping hand to hold this thing. Okay, well, it would help if I didn't have the shakes today. Sometimes I do, sometimes I don't. It just depends on the day. Alright, that's in now. That should be in the correct position. Nothing's bridged. Nothing's bridged. Should be free floating of ground. Was a good thing I checked it now, because if I'd plugged the DC in and went to test it, I would have shorted one of the supply rails out completely. So that should be V negative. No. Right, that's V positive there. That should be V negative, which it is. Two should not be shorted. And they're not. This should go to the output pin, which it does. And this should go where it needs to go. That one here should be also a ground, which it is. And I believe that middle pin should be a ground as well. No, one of these pins is a ground. That one, right on the end, is a ground. So for the input, that's a ground, then that should be high, that should be low, so that should be connected to that, which it is. That one should be connected to the high pin, which is on that resistor tag there, which it is. So this is all wired correctly, well, connector wise. And I'm going to have fun wiring those connectors. And some of these pins have sagged down too, even on the proper straight through connectors. That pin's sunk down a bit. So there's that one right there. Strange. Probably a little bit too much heat, and one on that did too. But the connectors are still functional. I don't like how they have sunk down a bit. But yeah, it is what it is. But anyway, that completes the construction of the PCB. Now I've got to do the wiring between the connectors to the pots and stuff. But first, I'm going to take a look at the front panel. Alright, so moving on to my front panel now. As you can see, I've got the sticky tape method going along here again. Again, masking tape would be a lot easier to see things, but anyway, I'm ghetto. I've marked all the main holes 30mm apart, and there's just enough room up this end for the master volume control plus the star earth point where the screw goes, and still clears where the preamp holes are. Now I'm going to ream one of these holes out a bit that way, probably one of these a bit that way, just to make the board square up a bit better, and just use washers on the outside to cover the messiness. It is what it is. Over here I've got a 20mm diameter hole to drill with a stepper drill bit in, I believe that's 30mm from the edge, or it could be 40, no it's 30. And back over here our inputs are also 30 in from the edge. Well no, actually that's 30 there, isn't it? We'll correct that, that's 40 in there and 40 in from there, and 30mm apart from each other. I've also got in for the pots an 8mm peg hole, guide hole, whatever that thing's called, for the little tab that's on the pot. And they're 8 mils apart. I checked the data sheet for the pots, the Alpha Taiwan pots, and it's 7.8, so 8 is close enough. And if you use a 3mm hole and an 8mm hole, because it's 7.5 I believe for the shank of the pot, there's enough wiggle room in there to get it in there. So that's going to be the next task, is to drill that. But speaking of pots, let's look at also what I got from Alltronics the other day. I've got one 10K linear pot, 18 tooth spline. That's R2225. I've also got two of these R2235s, which are 50K log by the looks of things. I've got R2237, which is a logarithmic 50K pot. And I've got two of R2227s, which are 50K linear. So these are for the tone control network. These two are for the treble and mid, I think, and the other one's for bass. I could have it the wrong way around. Also got two of these, which are Z278 5x2. These are any 5532 op-amp ICs. Yeah. The original circuit calls for a much higher performance op-amp, or you can use TL072s. I don't like TL072s because they are inherently noisy, and also I can't see the expense of using the OPA ones called for by the circuit.
One eternity later.
Okay, and a couple of days later I've got all the holes drilled to the correct size, and in case you're wondering what that noise in the background is, it's a fan over here. It's pretty hot today. Got some parts, got this power switch, which is an SP0704. That's going to be my power switch, which goes over here. And my hole is a little bit marred. Don't know if you can see it, but I'll try and zoom in on that. You can sort of see the edges where the drill came up into contact with the front panel. But that's alright, I can fill that in with a bit of black marker, and once the switch goes on there, it shouldn't really make much difference. It's only because it's marred the surface up here where it bit in a bit. But colour that in with a bit of black ink and you won't notice. But it fits in the hole nicely, that's the main thing. Now I'm going to put all the parts on loosely because it's all got to come back off anyway to do the labelling on the front. But what I might start with first is I might mount my preamp module into its new home. Got some HB 0400s, they're 6mm long M3 screws, and I have also got some HP 924. These are tapped nylon 12mm M3 hexagonal spacers. The problem with nylon spacers is they can't get them nearly as tight because you will strip them out. I might replace them with metal ones later, but for now I'm just trying to get the circuit board as straight as possible without having to ream the holes out if I can avoid it, because that just makes extra work and makes it look messy. So I'll just do it this way. If it's a little bit crooked, it's a little bit crooked. It's a home project, what do you expect? And that doesn't look too far off now. Doesn't look too bad. So at least the preamp's in there now. So I'm going to mount all the pots and other stuff on here, and I'm not going to do that on camera, I'll do it off camera because, well, yeah, it's kind of boring. One thing about these pots though is I'm going to have to bend these solder tag leads, because these are PCB mount. I'm going to have to bend them a little bit more at right angles so it clears the inside edge of the panel here. For some reason I've got two of these logarithmic 50k pots and I only need one. I must have ordered two by accident. But what I meant about, I've lost my pliers, oh there they are. What I meant about bending the pins up is, I meant just gently doing that. It's about 45-degree angle or something, just to help facilitate soldering to it inside as well, and also to make sure it doesn't short against the panel. I'll keep going now. Check it out, it's starting to look like an amplifier front panel. Yes, that power switch is crooked, but it doesn't really matter at this point. Back view, I've marked the back of each pot as to what they do so I know for reference. Those sockets are going to be awfully difficult to solder to in that position, but I'll work it out as I go. Isn't that so sexy? I think it is. Oh, yeah. Now we're talking. Okay, my orgasmic feeling aside, I've now got to consider wiring up all the pots and the sodding connectors I hate. I haven't got the bolt for this yet. I need a 15mm long M3 screw. Don't have it. The expense of today was kind of, we're talking in the $100 region here, just for all this hardware, extra hardware, the switch, these two sockets, the power switch. The spacers were like $12 for a pack of 25. Screws are $3.95. There was miscellaneous other components. I bought some wire, hookup wire, some audio wire, and a power transformer, which I'll show you now. This is one of the power transformers I'm going to be using. It's a 12 to 30 volt 100 VA 6 amp multi-tapped. So it's 0, 15, 0, 15 or 0, 30. I'm going to use two of these, and they're going to be wired in series to give me the bipolar supply I need. It's an double M2015, if that's coming on camera. I hope it is. It's a fairly weighty transformer, and it's a fairly big transformer. Check it out. So there's my fly leads for the AC connection, and there's 1, 0 and 15 tap, and over the other side is the other 0 and 15 tap. So you'd wire the 15 to the 0 and then take the 0 and the 15 on this side to make the 30. Or I could tap it off at 12 volt and get roughly 27 volts. It's really up to me to decide. But I'm going to use this to test the preamp on that power supply by wiring up the two separate 15 volt windings to give me roughly 21.7 volt DC plus minus. So 43 at the end of the day, and that should be enough to pickle that board inside the preamp front panel, just for testing purposes. And then this will finally be used for supplying that Electro India power amp. The rated output for each winding is 3 amps, so 6 amps total. Now there's going to have to be a primary fuse put on here, but they don't actually mark what the primary fuse should be, so there's an easy way to calculate that. So it's current primary equals volt amp rating divided by your voltage input. So in this case it's IP equals 100 VA divided by VAC, which I should write down as the correct voltage. It's 240 volt, so IP roughly equals 0.417 amp. So we're looking at a roughly half an amp for the primary winding. And it's going to be two of them, so that's a rough current of 1 amp. So a 1.5 amp primary fuse should be enough. You should use actually 200% of the current rating of the input for the fuse, but I'm going to use 1.5, 150%. And this power switch is rated at 1.5 amps, so it should be sufficient enough to power both these transformers without issue. Well, at least that's what I'm hoping. We'll soon find out when all's said and done. Anyway, I'm going to get on with wiring these sodding connections, which is going to piss me off to no end, and then I'll come back when I've actually got it wired. One thing I have to mention about the high-low sockets is its wiring. We're going to be joining the switch of the high connector to its ground pin, and then grounding it down to the low socket's ground, but we're not using the switched part on the low side, so it remains floating. When these sockets are disconnected, there's no plugs plugged in, they are internally shorted together. See how that these lay across each side. Now this one's the ground, that one's the actual ring side of the socket or plug. That comes into contact with this pin, outer pin out here. So that gets wired directly down to the ground on the other side, which is the unswitched portion, and wired to the ground on the side of this socket here. That's going to be my first task. So what might be easier is to run a piece of wire, tin copper wire, through the switched side, through to the ground, and then run it through to the ground on this side, and then take my ground point for the cable off the middle in between. I'll show you when I've actually done it so you can see what I mean. Yeah, that was the idea I was going for. See how it goes from the ring side when it's switched closed through to the ground over there on the opposite side, and through both ground connections on the other socket. So it goes from left to right, high, low. So that'll effectively bring R1, one side of it, to ground, which then turns this 100k resistor on R2 into a potential divider to make the low side circuit work. Anyway, I'm going to continue on wiring shit. Check it out, it's all wired, apart from the output socket. Did I mention I hate these connectors? I've learnt my lesson with these connectors. I actually soldered it to each of the tags and then crimped the end to jam the insulation into the crimp, because I've always had issues with bad connections with these things without the correct crimping tool. And as we look along the line, it's all wired roughly as Rod Elliott had suggested to do. You've got to keep the brightness switch away from the tone control network and the input cable as much as possible, or else it will oscillate. So that's done, it's ready for testing, but right now I'm going to go down to the pub before it closes and I'll test it when I come back. Pure Tasmanian, baby. I just realised I've got these two wires back to front. That's the low wire, the red one. The white one is the high wire. That's the high socket, that's the low socket. They're back to front. So the low is actually currently shorted out and the high is open, so it should be the other way around according to that connector anyway. The white one's in the middle, which connects to that point. The red one connects to that point. Okay, well, it's only a slight modification to fix that, so yeah, I'll bust out the soldering iron. I need to solder some wires onto the transformer anyway, so I'll fix that up and we'll come back when I've got the thing set up ready to test. Okay, so to test that I've wired the transformer correctly in phase, here's my setup. I've got a AC adapter lead that goes into you know, those laptop power supply bricks, with the wires shoved in the active and neutral. It's the safest way of doing it if I don't have a terminal block. Using my concoction of alligator clip and multimeter leads, that's set onto AC volt, connected across each end of the winding. One's a 0, one's a 15, and the other two are wired together, joined here. So when I plug this in now, we indeed have 31.85 volt AC. Not bad. Now I'll hook it up to the power supply, now that I know that's wired correctly. Okay, I've got the power supply hooked up. This is the first time this has ever been powered up, so hopefully nothing goes up with a bang. No, but the LED's lit up. That's nice. So I just need to do a voltage check here. So you focus on the meter and I'll just take those measurements again. We should have minus 21 volt there, which we do, 21.7. We should have positive 21.7, thereabouts. So yes, A, the power supply is working, and B, the transformer is working. So all well and good, we're off to a good start. Now to hook up the preamp module to the said power supply and see if we've got plus minus 15 volt across pins 8 and pin 4 of each IC socket. Alright, this is scary. Alright, plugged in. Pin 4 and pin 8, I believe that's pin 4 there, pin 8. Yes, we have 29 volts, nice. and also we have 29 volts across the other socket. So I know it's safe to plug the op amps in now. It's all getting really real at this point. Okay, I'm kind of nervous at this point. I've got the generator sitting at around about 600 millivolts connected directly to the low input connections. The oscilloscope is coming off the output. The chips are in. I'm about to plug the thing in and see if we get an output signal. The controls are around about halfway each, so hopefully we get a signal out on there. Carefully plug this in. Oh, indeed we do. Look at that. Work first time. Don't know if the wiring's correct yet. So, I will increase my input volume. And as we can see, that's what soft clipping does. If I increase my amplitude wherever that switch has gone. Now it's hard clipping, now it's soft clipping. So I'll turn that down. Now the mid control should do something. Does do something. I can see the waveform changing. Let me just change that. Actually, I might just increase the output a bit. No, I'll change that to ×1. The treble control won't do much to the signal, and the bass control won't do much to the signal, but if I put all of them down to 0, see, we no longer have an output. So that's how that tone control network works. So I'll switch frequencies. What are we at? Roughly a kilohertz. Now I'm currently getting roughly 178 hertz going through there, so the bass control should have some effect on that. Not by much, but it does. So I know that's doing something. Go right down to 140 hertz. It is doing something, but not how you would think. Let's change that to a lower frequency. About 33 hertz. It is doing something. So I know the bass pod is working. I'm going to go to 6.5 and change my time base again. About 1 millisecond. Yeah, the treble is actually affecting the overall output of the signal. So I can see that the tone controls are actually doing something. Yay! Okay, so with the tone controls at center again, master volume at max, I'm going to see what the actual total output is peak to peak before it starts to clip. Currently we've got 3.9 odd volt out, and it's starting to soft clip now, so I'm going to ballpark it around about the 3.5 volt peak to peak output, which is significant enough. All that work paid off, and that cluster of wiring paid off. It took me 2 hours or roundabouts to wire all those controls, and to have it work first time as soon as you power it up is brilliant. I'm absolutely stoked. Absolutely stoked. There's one more function I haven't checked, which is the bright switch. Now I reckon that operates around about the 3 kilohertz range. Okay, so currently we're at around about 4 kilohertz. Switch is off. Switch is now on, and we can see that the output increased a little. Switch it off. So we had 4.45 volt roughly thereabouts out when it switched off. We've now got 5.7 odd out when we switch it on. So I'll just play with the frequency control. we're not getting much. We're getting a little bit more increase above 4 kilohertz, but it starts to stop increasing around about, I want to say, the 12 kilohertz range, which is pretty okay. So its operating range is around about the 6 kilohertz mark, which is okay. Turn that back off. Now, what is the frequency response? Well, doing it with this sort of generator is hard, but I will start at the low end. Now we've got currently 0 kilohertz. Nothing's happening between the 1 to 100 hertz range at the moment. So that's full up. Let me just get some... Oh, there we go. That helps. Alright. So we're at roughly 0 hertz. Getting still 2 volt out. So 3.5, 3.7, 3.7 roughly, 3.8. So we start getting an increase around about the 100 hertz range. Okay, so it's 100 hertz so far. I'll just measure the top end, which is that way. Right, so bring that right down. Okay, we're at 3 kilohertz, 4.3 volts out, 4.4, 4.4, 4.4, 4.1. Okay, so we start cutting off around about the 10 kilohertz range. So it's around about 100 hertz to 10 kilohertz is the rough frequency response. So Rod Elliott has deliberately limited the frequency response of this. He's taken out the low end side because of the input capacitor. It's going to block a certain amount of frequencies. Around about the 100 hertz mark is where it starts to get a voltage increase. That stops the preamp having low end waffle, especially when using bass. Like, it just sounds like a lot of vibration noise in the speaker. And he's limited it at a roughly 10 kilohertz at the top end, which is fine. That's with the brightness switch off. Of course, putting the brightness switch on will boost it a little. But most guitars cut off around about the 8 kilohertz range anyway. So it's perfectly within the specs of a guitar anyway. It's not so much that great for keyboard or line input. You would have to modify the input capacitor of 1 to get the bottom end back again, and play with that 120 picofarad capacitor across each feedback resistor. But generally speaking, everything is working fine. Those are not getting hot. I am extremely happy, and I think I'm going to end this video here on a high. High? No, seriously. This is the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook, and you become a Patreon supporter for as little as $1 a month. Links are in the description. Anyway, this is the Astro 30 saying see ya. Have a great day. I am so happy.